Good morning, children. Today we will start another lesson. Second lesson. First lesson is completed. I hope all of you completed the notes. Now the second lesson, polynomials and factorization. In this lesson, you are going to learn what is an algebraic expression, what are polynomials, and how many terms are there, and degree of the monomials, polynomials, what is a linear polynomial, zero of the polynomial, zero polynomial, division of the polynomials, how to find out the factors for it, factor theorem, remainder theorem, etc. And we are using the new terms, but they are already known to you from your earlier class itself. So what is an algebraic expression is not a new concept, and what are polynomials are not a concept, a number of terms, not a very big concept to learn. They are very comfortable to you, and number of terms, degree of monomials, polynomials, etc., which you have learned in your earlier classes. We are going to find out the next step, or we are going to learn the next step of these polynomials and its factorization. 8th class, you have known these identities also. What are identities of the a plus b x, a plus b whole square, a minus b whole square, a plus b into a minus b, and its factorization also you have done. Find out the factors of it, or factorization. How do you divide the polynomials? Everything you have learnt in your earlier classes, and it is next only one or two steps ahead of it. But today we will learn the introduction part, and these notes you need to write in your notes, and you will be sent a notes later also, and that notes also to be written in your classworks. And next, as soon as the school reopens, we will check your notes. That is one thing. The other thing is, Monday you will be having a test on your first chapter. Prepare well for the test. Now, coming to the next one, define an algebraic expression and what are polynomials, or we call it as define a polynomial. What is an algebraic expression and what are polynomials? A definition of an algebraic expression is, in mathematics, an algebraic expression is an expression built up from integer constants. Constants means what? Numbers. You know what are meant by the numbers. Either they are the positive numbers or they are the negative numbers, whatever it is. Variables. So extra, that algebraic expression contains integers and variables also. What is meant by a variable? Already this is also explained to you. Variable means whose value varies from place to place or time to time. Like A, B, C are variables, X, Y, Z are variables, P, Q, R, S are variables, M, N, O are variables. They're all variables only. So similar, why do we use them? We use them to find out the value of an unknown content. There they are variables. And the algebraic expressions, operations. What are algebraic operations? They are connected with addition, subtraction, multiplication, and division. So here an example I'm citing, 4x square plus 5xy plus 6, where actually 6 we call it as a constant. 4x square is a variable, 5xy is also a variable because it is unite with a variable x and y, or x or y. Therefore, we call them as the algebraic expressions, and these are connected with what? Plus symbols. Plus symbol or minus symbol. When they are connected with either addition symbol or the subtraction symbol or division symbol or multiplication symbol, we call it as algebraic expression. In mathematics, an algebraic expression is an expression built up from integer constants. Means it will be containing the constants, variables whose value changes from place to place, time to time, and etc. And the algebraic operations also. What are algebraic operations? So any addition, subtraction, multiplication, division are called algebraic expression operations. Now, what is meant by a polynomial? In mathematics, try to understand in words. In mathematics, a polynomial is an expression consisting of variables and coefficients. Coefficients also means what? Multiplying the variable with a number, or numerical with a number. If it is multiplied, then it is called numerical coefficients. Or xy is there. What is the coefficient of x? Y. What is the coefficient of y? X. So they are called coefficients, and that involves only the operations of addition, subtraction, multiplication, and division also. Non-negative integer, that is more important. Non-negative integer means exponent must be with a non-negative integer. Powers should never have a non-negative. They are non-negative means a negative exponent should never be there for it. And exponentiation of the variables, that too for a variables particularly. For any of the constants, its degree is always equal to 0 only. Means what is the degree of 5? 0. What is the degree of 7? 0. What is the degree of 6? 0. Degree of all the constants are equal to 0. The variables, if nothing is mentioned, we have to take it as 1. For constants, the exponent is taken as 0. Now, I think you all understood. Means it is an expression consisting of the variables and coefficients that involves only the operations of addition, subtraction, multiplication, and non-negative integer exponentiation. Means what? Non-negative means what? The exponent should not be a negative number, and non-negative integer, that too. Integer means what? It should be either a positive integer. Non-negative means positive. It should be a positive integer, means exponent should be a positive integer. So exponent should not be a rational number. It should not be a fractional number. Means rational means I mean is it is a fractional number, or exponent should not be a negative number. So in that cases, we call it as a polynomial. Otherwise, it is not called as a polynomials. Now, pick out the polynomials among the given algebraic expressions. You are given x square as one expression. Now, x to the power of 1 by 2 plus 3, it is one expression. 2x square minus 3 by x plus 5, it is another expression. X square plus xy plus y square, it is another expression. See children, comma is given to you to find out the differentiation with it. Now x square is an polynomial only. It is a polynomial with a second degree because degree is equal to 3. Now x to the power of 1 by 2 plus 3, it is not a polynomial. Why it is not a polynomial? Here a variable is consisting of a non-negative, in negative, it is a positive only integer. 1 by 2, is it an integer? No. So here actually what is given? Non-negative integer. This is the basic condition to be satisfied. So no doubt it is non-negative, but it is not an integer. X to the power of 1 by 2 is not an integer. So here the exponent of a variable is not an integer. Therefore, this x to the power of 1 by 2 plus 3 is not a polynomial. Similarly, 2x square minus 3 by x plus 5, 3 by x. See, x is in the denominator. Suppose you are taking it to the numerator, then it becomes x to the power of minus 1. By 1 by a is equal to a to the power of minus 1. This is a radical. Already you know that 3 by x is equal to 3 to the power 3 into x to the power of minus 1. So when a variable is in the denominator, when it is taken up to the numerator, it becomes minus. Therefore it is again a negative integer. It becomes a negative integer. Therefore this is also not a polynomial. It is not that only 3 by x is not a polynomial. So when it is connected with the minus and plus or with anyone, total 2x square minus 3 by x plus 5 will not be a polynomial at all. No doubt of these three terms only, this term is not satisfying the condition of negativeness, non-negativeness. But still, the total polynomial is taken as not a polynomial. This is not at all a polynomial. I think you all understood. There are two conditions. The first condition is the exponent should be a integer, and the second condition is the variable should not be there in the denominator at all. If a variable is there in the denominator, its value will be a negative exponent when it is taken to your numerator. Therefore, it is non-negative, is not satisfying. Therefore, this is also not a polynomial. Now, x square plus xy plus y square, no doubt it is a polynomial. I hope you all understood that. The basically what is polynomial, you have to check two things. First one is non-negative number, and the next one should be integer. It should be an integer. It should not be a fractional number. 1 by 2, 3 by 4, 7 by 6 should not be there in the exponent. For a variable, then also it is not an integer, and it is should not be a negative number. It should be a positive number only. So in that case, it is a polynomial. Otherwise, it is not a polynomial. Say from this, we can come to a conclusion that the second expression and third expression are not polynomials. So 1 and 4th expressions are polynomials. In the second term, the exponent is 1 by 2, which is not an integer. And in the fourth expression, 3 by x is equal to 3 to the power of minus x is a negative exponent. It is having a negative exponent. X to the power of minus 1 is it? X to the power of minus 1. It is not 3 power minus x, 3 into x to the power of minus 1. This is not, and so x to the power of minus 1 means at power whole power n is equal to 3 power minus x. Okay, it is not, it 3 into, it is, don't write like this, 3 into x to the power of minus 1. So when a negative exponent is there, it is not a polynomial at all. So this is how you have to differentiate between the algebraic expressions and polynomials. It is an algebraic expression, no doubt it is an algebraic expression, but not a polynomial. Now, these polynomials are of again four kinds. Already you know that they are monomials, binomials, trinomials, and multinomials, and so on. Monomial means what? When a polynomial is consisting of a single term, say x square, it is a single term only. This algebraic expression, and it is a polynomial having x square, a single term, then it is called as a monomial. This is called as a monomial. Suppose if any exponent, if any polynomial which is having two terms, means x square plus 1, 3 square plus 3x plus y, and so on, they are called as what? Binomials having two terms. If an algebraic expression polynomial, if it should be a polynomial, and then the number of comes to. So first of all, check whether it is a polynomial or not. If it is not a polynomial, it cannot be taken as a monomial or a binomial at all. So if you are having a single term in the polynomial, you call it as a monomial. Two terms, then it is called as a binomial. When it is containing of three terms like 4x square plus 5xy plus 6, this is one term, this is one term, this is one term. Similarly, x square plus xy plus y square having the three terms, then it is called as a trinomial. And if it is consisting of more than three terms, then we call it as either a multinomial or a polynomial. The first condition, it should be a polynomial, and then if the number of terms are 1, we call it as a monomial. If number of terms are 2, then we call it as a binomial. Number of terms are 3, then we call it as a trinomial. Number of terms are 4, then we call it as more than 3, means it is a multinomial only. Now, coming to the next one, it is which of the following expressions are polynomials and which are not? Give reasons. If they are polynomials, you need not give the reasons. If they are not polynomials, you have to give the reasons. So first one, 4x square plus 5x minus 2. No doubt it is a polynomial which is having a second degree polynomial, second degree polynomial. Y square minus 8, it is also a polynomial of a second degree. Now 5, it is also a polynomial with a degree 0. Next, 2x square minus 3 by x plus 5 is not a polynomial because x have a negative exponent, x to the power of minus 1. Now, root 3 x square plus 5y is a polynomial. I told you it should not have any integer as a fraction as an exponent. For that is conditional only for the variable, not for the constant. Here, if you have root 3, it does mean that 3 to the power of minus 2, but variable is having a positive exponent only. We have to check only for the variables, not for the constants. So 3 to the power of 1 by 2, no problem, it is a polynomial only. Only for the variables, if it is there, then only we have to go that, we have to say that it is not a polynomial. So it is root 3 x square plus 5y is a polynomial. Understand? Now 1 by x plus 1 is not a polynomial because x has a negative exponent. A variable is in the denominator, so it has a negative exponent. Root x, it is not a polynomial because x is not in a exponent of x is not an integer. Say x to the power of 1 by 2. Root x means what? X to the power of 1 by 2. So 1 by 2 is not a integer, therefore it is not a polynomial. So x to the, it is not an integer, but it is a rational number. Means what? It is a fractional number. X to the power of 1 by 2 is not a polynomial. 3xyz is a polynomial only because it is satisfying both the conditions. So 3xyz is a polynomial. So I hope all of you understood what are called polynomials and what are not polynomials. So a summary of it is a polynomial should not have the negative exponent and also a fractional exponent. So polynomials will have only integers as positive integers as their exponents. Then we call them as the polynomials. Otherwise, we don't call them as the polynomials. Now, coming to the next concept. Write two examples of polynomials with one variable x. Means you have to check first. They should be a polynomial, and the next one, it should be having a single variable x. One variable means having only x or only b, only a or only b, anything. So polynomials with one variables are 4x square plus 5x plus 3. If you see the variables degrees are different, but the variable is same. Therefore, it is a polynomial with a single variable. Similarly, 3x plus 4, it is also called as a linear polynomial. Why it is called as a linear polynomial? Its degree is equal to 1. Whose degree is equal to 1, we call it as a linear polynomial. Here it is a quadratic polynomial because whose degree is equal to 2. So we call it as a quadratic polynomial. Second degree polynomial are called as quadratic polynomial. So 4x square plus 5x plus 3 is a quadratic polynomial and 3x plus 4 is a linear polynomial. But both of them are with a single variable. This is also a single variable. This is also a single variable. Now write three polynomials with a variable y. Now the polynomials with a variable y are 4y square plus 3y plus 8. This is one polynomial. Next 8y plus 2 is also a polynomial with a fun y only. Next one 4y cube plus 3y square plus 8y plus 9 means all the variables whose degrees are different, but they are having a single variable with y. These are all the polynomials. Three are the polynomials with a variable y with different degrees. This is called as a linear polynomial. This is called as a quadratic polynomial, and this is called as a cubic polynomial because the degree of this polynomial is 3. So here we call it as a cubic polynomial. Now, is the polynomial 2x square plus 3xy plus y square is in one variable? No, because we can see the two variables here, x and y. Here x is there, here y is there, but unitedly the total polynomial consists of two variables x and y. So this is not a polynomial with two variables x and y. Now write the formula of area and volume of different solid shapes. Find out the variables and the constants in it. I just gave you only the examples of areas, and I expect you to write the volumes, and I explain you also. So area of a circle, we take it as pi r square. In this pi r square formula, pi is a constant because whose value is 22 by 7 in all the cases are 3.14. So however it is called as a constant, and r is a variable. R value always changes. From the sum to sum it changes. Therefore, r is called as a variable. Now, total surface area of the cuboid, all of you know that 2 into LB plus BH plus HL, in which 2 is a constant where L, B, H are the variables. Here I have given you only the two areas. Now, but in the question I have given you the volume also. Now I expect you to write the answer for it. That answer also I am telling you. Volume of the, suppose you are taking the volume of the cylinder. Volume of the cylinder is equal to 1 by 3 pi r square h, in which 1 by 3 and pi are constants, r and h are variables. Similarly, area volume of a hemisphere or volume of a sphere, you take it as volumes exist only for the 3D pictures, not for the 2D pictures. 2D, two-dimensional pictures will not have volumes at all. So volume of a suppose you are taking volume of a cylinder, which is equal to 1 by 3 pi r square h. Similarly, volume of cone, 1 by 3 1 by 3 pi r square, sorry, cylinder is only pi r square h. Volume of cylinder is pi r square h. Volume of cone is 1 by 3 pi r square h. Volume of sphere is 4 by 3 pi r cube. Volume of a hemisphere is 2 by 3 pi r square h, pi r cube, and so on. In which you can opt the numbers as your constants, and the remaining are the variables. So you have to complete the notes as it is, and in your next video you will be starting with degrees of the polynomials and also the first 1.1 exercise, or sorry, 2.1 exercise. In the meanwhile, try to understand the concepts which I have explained you. Besides, you need to practice the chapter 1 and prepare well for your first test. These marks will be sent to sir. Thank you.